Circles, Part 2. Today, two goals. If we're not given the equation in standard form, like you can see in this slide, then you need to know how to convert it over to standard form. And secondly, once you do have it in standard form, make sure you can identify what the center and what the radius is of that circle. Okay, so let's begin. For this equation, we want to write the standard form of the circle. I'll go ahead and tell you, to do that, we're going to have to complete the square. In fact, not just once, but twice, because we'll have to complete the square for both the x values and the y values. But here's the good news. That may seem like a pain right now, but the process is really exactly the same for all the examples I have. So the first step is to make sure we just have one x squared and one y squared. In other words, we don't want any coefficients in front of x squared or y squared other than 1, and we're good to go as far as that's concerned for this example. Next, we need the constant, the number that's all by itself, to go by itself over the other side. So I'm going to add 9 to both sides and have that over there. The next thing I need to do is just change the order these terms are written in so that the x's are together. So I'll have x squared minus 2x, and the y's are together, y squared plus 6y. Alright, now we are ready to do completing the square. So we start by focusing on the x's. Before I do that, I just want to make sure I emphasize one more time what we did here. We added the constant over to the other side, so it was by itself over on the right side, and we reordered all the terms on the left so that the x's were together and the y's were together. So first we'll complete the square with the x's. Remember, we half the middle and square it. So we take the number in front of the x, in this case, the -2, we cut it in half, that's -1. And then we square it, that's +1, so we're going to add 1 to both sides. And then we'll do the same with the y's. We take the number in front of the y, which is 6, cut it in half, that's 3, square it, that's 9, so we add 9 to both sides. So you'll actually end up adding 2 numbers to the right hand side because you've had to complete the square 2 times. So we end up with x squared minus 2x plus 1 plus y squared plus 6y plus 9. And over here, that comes out to 19. Okay, now we factor. Remember, the whole point of completing the square is it becomes a square. And it turns out that you'll always end up with the term right after the x or the y being exactly half of that middle term. So cut -2 in half, it's -1. That's it. Because when you factor x squared minus 2x plus 1, you'll get x minus 1 times x minus 1, which we can then combine into x minus 1 squared. Same idea over here with the y. It's always going to end up being exactly half this number, so it's y plus 3 squared equals 19. So now we have the circle in standard form. Sorry about that. Now that we have it in standard form, it should be very easy for us to then identify what is the center and what is the radius. Remember, we're always subtracting those values. So over here we have x minus 1, we're subtracting 1. So we have 1 as the x value. And what we're actually subtracting right here is a -3, because it's y minus -3 gives us +3. So we'll have -3 as the y value of the center. And the radius, remember, we always squared the radius to get this part right here. This part is equal to r squared. So to get the radius, we just take the square root of that, and we get the square root of 19. So if you notice, for the center, we really just look at these numbers and then flip the signs. We had a -1, so we change it to a +1. We had a +3 or a +3, then we change it to a -3. And then 19, we took the square root of that to get the radius. Okay, this example be the same basic process. The first thing we need to do, which I mentioned last time but we didn't have to do anything with it, is we have to make sure the coefficients in front of x squared and y squared are just 1. But this time they're not. It's a 2. Well, we can't complete the square, which we're going to need to do soon. We can't complete the square when we have those coefficients there. So what we have to do is actually divide everything, every single term, by 2. So the first thing I will do is divide every single term in this equation by 2. So that turns out to be x squared plus y squared minus 2x plus 6y minus 9. So that's step 1. Now we checked that last time but didn't have to do anything. This time we did. So then we go from there and do the same process as last time. We add the 9 to both sides and we reorder this so the x's are together and the y's are together. And yes, you may notice this actually turned out to be the exact same thing as the previous example. We just had to do that first step of dividing by 2 first. So we'll go ahead and make sure we keep going for the sake of routine, getting a good handle on this. To complete the square, we look at this number and we cut it in half. So negative 2 divided by 2 is negative 1. Then we square that, it's positive 1. We add that to both sides. Then for the y's, we take this number, cut it in half, that's 3. Then square it, that's 9. Then we add 9 to both sides. Oh, sorry, no squared there. Okay. Then the last step is to factor, which again, just remember, this number, if you just cut it in half, that's what you end up with here. So x minus 1 squared, y, half of that is plus 3 squared. And just like we talked about, the center is these two numbers, but flip the sign because they're being subtracted, so it's a positive 1 and a negative 3. And to get the radius, you take the square root of this number, and you do need to leave it as the square root of 19. Do not write it as a decimal. Don't do it. So we write it as the square root of 19 for the radius. Okay, last example. Given 4x squared plus 4y squared minus 24x plus 16y equals negative 48. Okay, step 1, like we've talked about, we have to make sure the coefficients in front of the x and the y are just 1. So this time we'll have to divide every single piece by 4. Now some of you may be saying, well, what if those two numbers aren't the same? That's a fair question. The good news is, as long as you're dealing with circles, they have to be the same. So if those two numbers aren't the same, then it's not a circle. So in the context of circles, the two coefficients in front of x squared and y squared will always be the same. So when we divide all those pieces by 4, we get x squared plus y squared minus 6x plus 4y equals negative 12. So notice the constant, the negative 12, is already over by itself. So that part's done, but we do need to change the order of the terms so that the x's and the y's are together. So all I did there was put the x squared minus 6x together and the y squared plus 4y together, and I leave the negative 12 off to the side by itself. Okay, now is where we complete the square. So I look at the term in front of the x, cut that in half, that's negative 3, square it, that's 9. So I add 9 to both sides. So I'm good to go with the x's. With the y's, I take this term, I cut it in half, that's 2, square it, that's 4, so I add that to both sides. So I end up with x squared minus 6x plus 9 plus y squared plus 4y plus 4, and that's going to equal just 1. 9 and 4 is 13, negative 12 plus 13 is 1. So our last step is to factor. Remember the beauty of completing the square. Turns out when you factor it, it's just going to be half of this number. So this will turn into x minus 3 squared, and half of that number, y plus 2 squared, is equal to 1. So just in case you're watching this video and you aren't as familiar with that shortcut on completing the square, if you factor these, this one would turn into x minus 3 times x minus 3, which you can then simplify to x minus 3 squared. This one would simplify to, factor into y plus 2 times y plus 2, which you can then simplify to say y plus 2 squared. But when you're completing the square, this isn't a magic all factoring trick, but when you're completing the square, it turns out that this value right here always is exactly half of this value right here. So that saves you some time. Lastly, we find the center. So we're subtracting the 3, so the x value is 3. We're subtracting a negative 2 right here, so negative 2. So you can just think about it if you want as you're flipping the signs. And then the radius, the square root of 1, is 1. If it does come out whole like that, please don't leave it as the square root of 1, just write 1. Or if it had been 16, don't write the square root of 16, just write 4. But if it's not a whole number, then please just leave it in its radical term. So that completes circles, part 2.